Purification of cells from human peripheral blood. Mononuclear cells, lymphocytes plus monocytes. Monocytes. Polymorphonuclear leukocytes, PMNs, or granulocytes. Platelets or thrombocytes. One of the most important areas for applications of axis shield density gradient media is the purification of leukocytes from human blood. Density of human blood cells. 1.060, 1.070, 1.080, 1.090, 1.100. Cell number. Density, G/ml. Monocytes. Lymphocytes. Basophils. Neutrophils. Eosinophils. Erythrocytes. This graphic shows the density of human blood cells. The polymorphonuclear leukocytes comprise basophils, neutrophils and eosinophils and have densities above 1.077 to 1.078 grams/ml, while the mononuclear cells, which comprise lymphocytes and monocytes, have densities below this value. Hence the density of commercial media for the isolation of human peripheral blood mononuclear cells is 1.077 to 1.078 grams/ml. Mononuclear. Polymorphonuclear. Leukocytes, isolation of human mononuclear cells. Density barrier method. 1.077 grams/ml. MC. PMNs. RBC. 600 grams. 15 minutes. When whole blood is layered over a medium of 1.077 grams/ml, the mononuclear cells, MC, band at the interface, and the red blood cells, RBC, and polymorphonuclear leukocytes, PMNs, pellet. Axis shield density gradient media for isolation of human PBMCs. Lymphoprep, 9.1% ditrizoate, 5.7% polysaccharide, 1.077 grams/ml, 295 mOs, endotoxin less than 0.13 EU/ml. Nicoprep 1.077, 14.1% nicodens, 0.44% NaCl, 5-tricine-RO, pH 7.0, 1.077 grams/ml, 295 mOs, endotoxin less than 0.13 EU/ml. Optiprep, endotoxin less than 0.13 EU/ml, diluted with any suitable balanced salt solution or culture medium to give a 1.077 grams/ml medium, CO3. Only Axis Shield offers three options to the isolation of human PBMCs. Lymphoprep is the most widely used medium and comprises ditrizoate and polysucrose. There is evidence that the polysaccharide that is present in Lymphoprep and all the other commercial PBMC isolation media may adhere to lymphocytes. If this is a concern, then only Axis Shield offer a polysaccharide-free alternative. Nicoprep 1.077 has the same density as Lymphoprep. It contains nicodens, NaCl and a buffer but no polysaccharide. The third option is to make up a 1.077 grams/ml from Optiprep by dilution with any cell-compatible medium. This can be therefore tailored to the operator's own requirements. All the options have the same very low endotoxin levels. Separation of PBMCs on Lymphoprep. Blood saline 1:1. Blood less than 12 hours old. 6 ml diluted blood on 3 ml of Lymphoprep. The recommended protocol is to dilute blood 1:1 with saline and layer 2 volumes over 1 volume of Lymphoprep. The result above shows the banding of PBMCs from 6 healthy donors after centrifugation at 600 grams for 20 minutes at 20 degrees Celsius. The blood should be processed as soon as possible after drawing and should certainly not be used if more than 12 hours old. Lymphoprep competitors. FicklePack, GE Healthcare, Examersham and Pharmacia. Histopac 1077, Sigma. Not endotoxin tested. More expensive endotoxin tested versions, for example Sigma's Histopac 1077 Hybrimax. Competitors for Lymphoprep are FicklePack and Histopac. The basic versions are not endotoxin tested, but more expensive versions that have low endotoxin levels are available. Axis Shield makes it easy. 1 medium, Lymphoprep, that is endotoxin tested and less than 0.13 EU/ml. Lymphoprep queries. I. Anticoagulant? Not anticoagulant sensitive. Do I have to dilute the blood? Whole blood less easy to layer, poorer percent yields. Can increase sample lymphoprep ratio. Yes, but not recommended. Can I use a leukocyte-rich plasma? Yes, okay to separate PBMCs and PMNs. Centrifugation at 4 degrees Celsius rather than room temperature? Yes, but need to increase time by 5 minutes. Main customer questions on lymphoprep. Any anticoagulant may be used, pre-coated tubes may be used, but for the retention of the best function of leukocytes we recommend mixing the blood by gentle inversion with an isoosmotic solution of the chosen anticoagulant. Whole blood may result in yields as low as 70%. If the volume of diluted blood is increased, the G-force experienced by the cells at the top of the sample will be much lower, so it may be necessary to increase the centrifugation time. For larger volumes of blood we strongly recommend keeping to the usual 2:1 diluted blood lymphoprep ratio in a larger tube, 6 ml over 3 ml in a 15 ml tube and 20 ml over 10 ml in a 50 ml tube will give optimal separations. A leukocyte-rich plasma is fine, it need not be diluted. At lower temperatures the centrifugation time needs to be raised to overcome the increased viscosity of the medium. Lymphoprep queries, 2. Fickle pack or histopaque work better? Impossible, media have identical composition. Poor definition of PBMC banded interface. Poor layering technique and or break problem. Poor separation from erythrocytes/PMNs. Blood greater than 12 hours old, clinical specimens. Can I use it for non-human blood? Maybe primates and some ruminants. How can I remove the platelets? Other questions re lymphoprep usage. All the commercial human PBMC have the same composition, except for the higher endotoxin levels of some products. Mixing of the diluted blood with the lymphoprep during layering will cause band broadening. A slow deceleration program or no braking are recommended to avoid the creation of a vortex in the liquid due to rapid changes in RPM. Some clinical specimens may give inferior separations. Lymphoprep, Nornicoprep 1.077, are recommended for blood from other species, although some publications have reported its use for monkey blood. Anecdotal evidence also suggests that it has been used for bovine and equine blood. For blood from rodents and rabbits see slides 31 and 32. All of the platelets will be recovered in the PBMC band. These are often removed by repeated washing with saline using repeated centrifugation at approx 200 to 300 grams for 10 minutes to pellet the PBMCs preferentially, but the process is time-consuming and not very efficient. PBMCs are lost to the supernatants and platelet contamination of pellets is persistent. More efficient methods for preparing platelet-free human PBMCs are given in slides 12 and 13. Lymphoprep tube blood diluted 1:1 with saline 800 grams for 15 minutes PBMCs. Lymphoprep TM. Plastic frit. PBMCs. Medium. Displaced. Upwards. Blood diluted 1:1 with saline. 800 grams for 15 minutes. The lymphoprep tube is suited mainly to those customers who have to carry out multiple separations of PBMCs. The tubes are pre-filled with lymphoprep, which is contained beneath a porous plastic frit. The diluted blood may be poured, rather than laid, onto the frit. During the centrifugation the erythrocytes and PMNs pass through the frit and the medium to form a pellet, which displaces the lymphoprep upwards, allowing the PBMCs to bend at the interface above the frit. Once the centrifugation is complete the liquid above the frit can simply be decanted to recover the PBMCs. 2 tube sizes are available, one with 2 ml of lymphoprep and one with 10 ml. The recommended volumes of diluted blood must be adhered to. Isolation of PBMCs by flotation, mixer method, CO4. 1.25 ml. OptiPrep. 10 ml blood. PBMCs. PMNs plus. RBCs. Plasma plus. Platelets. Saline. 1,500 grams. 30 minutes. Another strategy which avoids the layering of diluted blood on top of a barrier is to mix whole blood with OptiPrep, as shown in the graphic. The OptiPrep mixes with the plasma to raise its density to 1.078 grams/ml. A small volume of saline is laid on top, and during the centrifugation the PBMCs float to the plasma/saline interface and the red blood cells and PMN's pellet. The saline prevents the PBMCs banding at an air/liquid interface. Problem with mixer method. Ratio of cells plasma, hematocrit value. Normal males, 42 to 54%. Normal females, 38 to 46%. Some clinical samples may have significantly lower values. Although this mixer strategy is very simple, it does suffer from one problem, and that is that different blood samples have different hematocrit values, that is different cell plasma volume ratios. Thus the lower the hematocrit, the lower will be the final density of the plasma plus OptiPrep mixture. The higher the hematocrit, the higher the density. Removal, isolation, of platelets on a density barrier, C12. 5 milliliters of 1.063 grams/ml. 5 milliliters whole blood, platelets, leukocytes, plus RBCs. 350 grams. 15 minutes. The method described in application sheet C12 is a simple low-density barrier over which is laid whole blood. During the very low-speed centrifugation, only the leukocytes and red blood cells are large enough to sediment into the pellet. The much smaller platelets form a broad band below the interface. Published papers report the excellent yields and function of platelets purified in this manner, see C12. The method may also be used to remove platelets from any leukocyte fraction. PBMCs harvested from a 1.077 grams/ml barrier interface must be diluted with an equal volume of saline before layering on the 1.063 grams/ml barrier. Isolation of platelet-free PBMCs, CO5. Blood plus OptiPrep 1.095 grams/ml. 1.077 grams/ml. Saline PBMCs, PMNs, plasma plus RBCs, plus platelets. 600 grams. 20 minutes. There is also a one-step flotation strategy for purifying platelet-free PBMCs from whole human blood. Blood is mixed with OptiPrep to raise the density of the plasma to approx 1.095 grams/ml. A 1.077 grams/ml barrier, also prepared from OptiPrep, is laid on top plus a small volume of saline. During the centrifugation the PBMCs float to the top interface and all the other cells and platelets remain at the bottom. This is a photomicrograph of the PBMCs isolated from the flotation gradient. Without washing, maybe just 2 platelets can be identified. 13.8% ditrizoate, 8.0% dextran 500 density equals 1.113 grams/ml. Axis shield density gradient media for the isolation of human PMNs from whole blood. Polymorph prep. 13.8% ditrizoate, 8.0% dextran 500. Density equals 1.113 grams/ml. Osmolality equals 460 mOsm. Polymorph prep is a high-density medium containing ditrizoate and a polysaccharide that has a raised osmolality, approx 170 mOsm greater than that of plasma. Separation of PBMCs and PMNs on polymorph prep. Whole blood. 5 milliliters. Polymorph prep. PBMCs. PMNs. RBCs. 450 to 500 grams. 30 to 35 minutes at 20 oc. Polymorph prep is the only medium that will separate PBMCs, PMNs and red blood cells from whole blood, using the format shown in the slide. How does polymorph prep work? 1, 2, 3, 4. Polymorph prep works in the following manner. Red cells are the only cells dense enough to enter the medium at the start of the centrifugation. The graphic shows 1. A red cell entering the top of the polymorph prep. The much higher osmotic pressure of the medium causes water to exit the cell, thus diluting the polymorph prep, thereby reducing its density. The osmotic pressure inside the red cell and its density increase. 2. When this red cell sediments further into the medium, the difference in osmolality between the cell and the medium is reduced, consequently less water is lost and the medium is diluted to a lesser extent. 3. Further down the column of polymorph prep, the difference in osmolality is again reduced and even less water is lost to the medium. 4. The progressive reduction in the loss of water from the sedimenting red cells thus generates a density gradient. In the graphic, the gradient, for convenience, is illustrated as discontinuous. In reality, the gradient that is generated is continuous, and it is across this gradient that the PBMCs and the PMNs are separated. Polymorph prep separation. Here are two examples of the PBMC, top band, and PMN, bottom band, separation in polymorph prep. On the left is a photo of a separation carried out in 1988, the right a separation in 2008. Call to STKR analysis of PBMCs and polymorphs. 4, 8, 12, 16, 20, 24, 28, 32. Cell volume, femtoliters x 0.1. Relative number. The call to STKR analyzer essentially provides a cell volume analysis of a cell suspension. No PMNs are lost to the PBMC band. The PMN band contains approx 5% PBMCs. Polymorph prep, critical points. Must use fresh, less than 2 hours old, whole blood. Anticoagulant must be EDTA, dipotassium. Temperature must be 1822 C. Blood medium volume ratio must be 1:1. 5 ml plus 5 ml in a 15 ml tube. Brake must not be used. Centrifugation time can be plus 5 minutes. Recommended G-force is the GAV. Note, even though the original paper describing this method recommended heparin as an anticoagulant, our own experience shows that EDTA provides more reliable results. Unlike the protocol for lymphoprep, which recommends the use of diluted blood, this method will only work with whole blood, and nothing else. For explanation of GAV, see next slide. Geometry of rotors. Set RPM speed to give 500 grams at max. Axis of rotation. Max. Rav. Ren. Set RPM speed to give 500 grams at max. The selection of the correct RPM to provide 450 to 500 grams is critical to the success of the method. The description of the G-force is that at the RAV of the tube, that is, the GAV, allows the selection of the correct RPM for different rotors and different tubes. In many modern benchtop centrifuges it is possible to set the G-force directly, but this is always the at the max. In the majority of these centrifuges, 650 max is approximately equivalent to 500 GAV. For more information about the geometry of rotors, see Training File 1, Slides 2 to 5. Equivalent to 400 grams at RAV. Polymorph prep / sample volumes. The distance from the bottom of the tube to the interface and to the meniscus of the blood that is obtained when using the standard format of 5 ml plus 5 ml in a 15 ml tube, must be maintained when either larger or smaller volumes of blood and medium are used. Human PMNs from a leukocyte-rich plasma, CO11. 1.077 grams/ml. 600 grams. 20 minutes. PBMCs. An alternative method for the isolation of human blood PMNs is to layer a leukocyte-rich plasma over a layer of 1.077 grams/ml. Lymphoprep, Nicoprep 1.077 or a solution prepared from OptiPrep. In this situation the PMNs, plus any residual red blood cells, form a pellet. PMNs however become activated when pelleted, and a better strategy is to band them at an interface. Inclusion of a cushion of 1.10 grams/ml, or 1.095 grams/ml, density achieves this optimal situation. 1.10 grams/ml. PMNs. Axis shield density gradient media for the isolation of human monocytes, barrier sedimentation, C55. 13.0% nicodens, 0.58%, WV, NaCl, 5-tricene-RO, pH 7.0. Density equals 1.068 grams/ml. Osmolality equals 335 mOsm. A customized medium for the isolation of human monocytes, Nicoprep 1.068, is no longer available. but this medium with a slightly raised osmolality can be prepared easily from nickel-dense powder or from OptiPrep. Density of human blood cells 1.060, 1.070, 1.080, 1.090, 1.100. Cell number. Density, G/ml. Monocytes. Lymphocytes. Basophils. Neutrophils. Eosinophils. Erythrocytes. In a leukocyte-rich plasma, lymphocytes are the most osmotically sensitive cell type. In a medium of slightly raised osmolality, the density of lymphocytes is therefore selectively increased, thus the difference in density between monocytes and lymphocytes is artificially enhanced. Separation of monocytes on 335 mOs, 1.068 grams/ml barrier. LRP. M. L. Harvest. Zone. 600 grams. 15 minutes. A leukocyte-rich plasma is laid over the medium, 2:1 VV. After centrifugation, a pellet and a turbid layer between the pellet and the interface are observed. The pellet contains PMNs and lymphocytes. Monocytes are enriched in the top half of the turbid layer, low-density lymphocytes in the bottom half. After removal of the bulk of the plasma supernatant, the monocyte-containing region, between the dotted lines, must be harvested very gently to avoid sampling of the lymphocyte zone. NiCaPrep 1.068 requirements. Leukocyte-rich plasma, not whole blood. Anticoagulant, EDTA. Blood from normal individual, less than 2 hours old. Room temperature 18 to 22 degrees Celsius. No break to decelerate rotor. Centrifugation conditions may need optimizing from lab to lab. If the centrifugation conditions are strictly adhered to, the method is very effective and the purity of the monocytes is approx 90%. Ideally, a slow acceleration program should be used if available. Flotation of monocytes from leukocyte-rich plasma, CO9. HPS. 1.068 grams/ml. 1.084 grams/ml. LRP. LC. M. L. P. 600 to 800 grams. 15 to 20 minutes. More recently, a flotation method has been developed for monocyte purification from a leukocyte-rich plasma, LRP. OptiPrep is added to the LRP to raise its density to approx 1.1 grams/ml. The leukocytes rapidly float to the top of this sample zone during the centrifugation to form a sharp zone at the lower interface, from which the monocytes float more rapidly than the lymphocytes. At the end of the centrifugation, the monocytes form a diffuse band below the top interface. Lymphocytes and PMNs are enriched at the lower interfaces. Fax analysis of monocyte band Graziani Bowring, G. M. et al., 1997 J. Fax analysis of monocyte band Graziani Bowring, G. M. et al., 1997 J. Immunil. Meth. 207, 429 to 436. Surface marker. Percent events. CD3+. 3.4. CD14+/C.D. 4. 1.6. CD14/C.D. 4+. 6.9. CD14+/C.D. 4+. 84.1. All monocyte markers. 92.6. The purity of the monocytes is very high, but the yields are variable. Yields are improved by a slight increase in the ionic strength of the density gradient solutions. See application sheet CO9. Monocyte flotation isolation queries. No monocyte band observed. Band may be quite diffuse. Poor recovery and purity of monocytes. Rapid preparation of leukocytes essential, and handling of cells must be very gentle. Does method work at 4 degrees Celsius? Probably. As with all monocyte methods, the gentle handling of the leukocyte-rich plasma and rapid processing of the blood is critical to the success of the method. Carrying out the centrifugation at a low temperature may improve the yields, as one reason for poor yields may be phagocytosis of the dense medium by activated monocytes, which is eliminated at 4 degrees Celsius. This has not been tested and it may be necessary to increase the centrifugation time to account for the raised viscosity of the solutions. Axis shield density gradient media, isolation of rodent PBMCs, sedimentation onto a barrier, C43. Dilute buffered saline with water, 2.5:0.5, solution is 242 mOsm. Dilute OptiPrep with the 242 mOsm solution, 2.7, 9.3. Solution of 1.077 grams/ml and 265 mOsm. Competition, Histopaque 1.083, 1.083 grams/ml, 295 mOsm. A customized medium for the isolation of mononuclear cells from rodent and rabbit blood, NicaPrep 1.077A, is no longer available. It had an identical density to LymphaPrep and NicaPrep 1.077, 1.077 grams/ml, but a slightly reduced osmolality. An identical solution can be easily prepared from OptiPrep according to this schedule. The main competitive product, Histopaque, is isosmotic but has a raised density. Axis shield density gradient media for the isolation of rodent PBMCs. 1.060, 1.070, 1.080, 1.090, 1.100. Cell number. Density, G/ml. Monocytes. Lymphocytes. Basophils. Neutrophils. Eosinophils. Erythrocytes. Compared to the lymphocytes of human blood, those of rodents have a high density. Hence the density of the competitive product, Histopaque 1.083, is 1.083 grams/ml, and this will allow the efficient isolation of the mononuclear cells, but the density of the PMNs is the same as that of human PMNs, so the mononuclear cells will be contaminated by these cells. In the Axis shield version, the density of the lymphocytes is selectively reduced by the low osmolality medium. The density of the PMNs is unaffected, so the mononuclear cells are uncontaminated by PMNs. Rodent PMNs from leukocyte-rich plasma, C45. Isotonic ammonium chloride. Aspirate. 1.077 grams/ml. 265 mOsm. LRP. MC. RBC plus PMNs. 600 grams. 20 minutes. This reduced osmolality medium can also be used to harvest rodent PMNs from a leukocyte-rich plasma. After the centrifugation, the mononuclear cells are at the interface and the PMNs and residual red blood cells are in the pellet. All of the liquid above the pellet is aspirated and the red blood cells are lysed selectively using ammonium chloride. Common flotation strategy for purifying low-density cells from tissues. Isolation of dendritic cells from spleen, thymus, lymph nodes etc., C20. Tissue disaggregated using enzymes. Cell suspension adjusted to 1.085 grams/ml. Make-up solution of 1.065 grams/ml. The modern flotation technique that was developed for the isolation of human monocytes has been recently adapted to the isolation of a large number of low-density cells. One of the most widely used applications is the purification of dendritic cells from tissues by the method shown in this slide. Dendritic cells, flotation strategy Reed, C. et al., 1996, year, J. Dendritic cells, flotation strategy Reed, C. et al., 1996, year, J. Immunil, 26, 1801–1806. 1.065 grams/ml. 1.085 grams/ml. Sample. Saline or culture. Medium. Dendritic. Cells. 600 grams. 15 minutes. The advantage of this flotation strategy is that all the denser cells, any cell debris resulting from the tissue disaggregation process and any residual enzymes remain in the sample zone and are separated from the banded dendritic cells by a clean layer of the 1.065 grams/ml solution. Pancreatic islets, flotation, C18, Van der Berg, P. M. Pancreatic islets, flotation, C18, Van der Berg, ppm, 1998, Transplant. Brock. 30, 362 to 363. 1.09 grams/ml. 1.10 grams/ml. Islets. Asina. Cells. OptiPrep. PEG. Yield. 92%. 58%. Purity. 86%. 61%. Viability. 75%. 54%. 500 grams/5 minutes. Another very important application of the flotation strategy is the isolation of the insulin-producing islet cells from the pancreas. Development of a reliable method is crucial to the possible use of the islets as implants for diabetic patients. The method is another example of the use of a slightly raised osmolality for the cell suspension, which selectively increases the density of the acinar cells to promote good separation from the islets. In terms of all the important parameters, the OptiPrep method is much better than the traditional method using histopeg. See table. Interestingly, if the G-force is reduced to 100 grams, the yield, purity and viability all increase significantly, approx 95% in all cases. Removal of non-viable cells, C13. Cell suspension. Adjusted to 1.15 to 1.16 grams/ml. 1.12 grams/ml. Culture medium. Viable cells. 800 grams. 20 to 25 minutes. The recovery of viable cells from a suspension containing non-viable cells is also best carried out by flotation. Again, all the non-viable cells, cell debris and released components from non-viable cells remain in the sample zone and are separated from the lower density viable cells by the clean 1.12 grams/ml layer. Other axis shield cell applications. Epithelial cells from gastric mucosa, C28. Neurons, spinal cord, C22, brain, C29. Human erythrocytes and reticulocytes, C35. Megakaryocytic progenitor cells, C23/C48. Pneumocytes and other lung cells, C25/C44. Stellate cells from liver and pancreas, C33. Hepatic Kupffer cells, C50. Renal cells, C42. There are 55 application sheets that can accessed either on the Axis Shield application CD or from the website www.axisshielddensitygradientmedia.com.